Hello, my name is Dennis. I'm from Berlin, Germany, and this is my contribution to the Embarcadero Delphi showcase. My passion are compilers, parsers, and scripting engine, and that's why I'm contributing a scripting language. Many of you will know the common scripting solutions available to Delphi. This includes Delphi WebScript, RAM Object Pascal Script, and others. But few of you actually have noticed that all of these are imperative languages. So what I thought might be a good idea is creating a functional programming language as a scripting engine for Delphi. After having worked with some script engines that are already there, and also having worked with some functional languages in the past, mainly for academic purposes, I designed a completely new functional programming language written in Delphi. It allows anything that most common functional languages have, such as functions and other things like types, constructors, but also some unique new features and some features transported from Delphi. The language is kind of Pascal-like, with some of the extensions and features of C combined with Haskell and other languages. The compiler runs on any platform, including mobile and desktop platforms. In my repository, that is linked in the showcase, you can find the editor that you're seeing here, but also a command line compiler and a app that's running on both desktop and mobile applications. I've also included a screenshot of it running on Android. Of course, the parser library is also included, and it's easy to use within your own applications. Alright, I'd like to show you some of the features this language has. All commands can be divided into three categories: expression terms, declarations, and special commands. First we're gonna head into direct expressions. If I write 1 plus 2, this is direct expression, and if I'm gonna run it, it gives 3. This is very simple, but they're gonna be a bit harder when we discover more features. Secondly, there are declarations. For declarations, there are different kinds available. The first one would be a named constant. We declare them similarly as in Delphi, with a const keyword, some identifiers, and an equal sign and a value. In this case, we're going to declare a constant with the name a and the value 1.5. If we now write a, this is going to be 1.5. Let's see. Alright. Secondly, there are variables. Variables are declared with a var keyword, similarly as in Delphi. Var a, and now we can either enter an initial value, like 2, or we leave it for free, then it's initialized to 0 by default. We can change this behavior in the options and define a known initial value type. Number is the default. Reference, string, array, and record are also available. You can change the variable's value by redeclaring it. If we first declare it now, it should have the value 0. Let's see it. 0. If we redeclare it, we're changing its value to 1. If we run it now, it should show us 1 at the second output. Last but not least, I'd like to show how to declare a function. Let's declare a function with the name foo. Now, as in Delphi, we could either put some arguments expected to it or just leave it free. We can omit the parentheses in this case. We're also declaring it with the equal sign followed by the value to be returned. In this case, we want to have an add function which adds two values, a and b. So we write a plus b. Now we can also constrain the values to be only accepting certain amounts of types. For example, if we want only to add numbers, we just write number as the type identifier. We cannot overload functions, but we can define default values, similarly as in PHP. If I want to have a default value, I write equals and the default value. One important difference between Delphi and MFL is the use of commas to separate parameters instead of semicolons. If you want to have two or more identifiers glued together, sharing the same default value and type, similarly as in Delphi with the comma, you can use the and sign here. A and b were both numbers and both now have a default value of 0. Let's try it out. Write foo 1, 3, and it should give 4. If we leave out 1 parameter, it should give 1, and if we leave both or simply remove the parentheses as well, it should give 0. As operators, there are the following standard operators available: plus and as an addition, minus as a subtraction, times as a multiplication, divide through as a division, modulo as the modulo in C style, exponentiation, and some special operators, like the rounding operator to round a number mathematically correct, and the sign operator, which can also be used for comparison. Like in most C-style languages, strings are encoded with double quotes, followed by any kind of Unicode string, and ended with a double quote again. Arrays are introduced with brackets, followed by any kind of values, and ended with a bracket as well. Objects are introduced with brace, then there is an identifier, an equal sign, a value, and to end the object, we'll use the other brace. As data types, there are different types for variables and values available. The first and default value is a number. This supports any kind of numeric value, including floating point numbers, special values like infinity or not a number, but also standard numbers like 1, 2, 2.5 or -1. References are created using the @ sign, similarly as in Delphi. Add and an identifier returns an address that can be dereferenced later on. You can add comments by using the backslash. Either the comment is being ended by another backslash, or it goes to the end of the command. In the system package, but also in the other built-in packages available, you find a lot of predefined constants and functions available to you. These include the scene function, p constant, infinity constants, and others. There are many more functionalities on this language available. However, I want to show you one more specific thing, and that's more about references. So we can have references as arguments of functions, but also in direct values like constants. If we declare a function that calls any given other function, it takes a reference of the type ref, if we want so, and also arguments, as an array with the default value of an empty array. We dereference R using the sharp key, and by dereferencing it, we have to directly supply all the arguments that are required for a call. Like for a function or for a value that we don't know, we have the arguments provided in the args argument. If we want to spread an array towards arguments, like for example in JavaScript with the spread operator, we can do it here with the spread keyword. This will spread the args array upon arguments of R. If we now call the function call, we can call it with sinus and any value we want, like 1.5. This will return us the scene of 1.5. We can also do anonymous functions using func and ret keywords. Func to introduce the anonymous function, then we supply any kind of arguments as we know from standard functions like a and b, and instead of the equals sign we use the ret keyword followed by the value that should be returned, like a plus b. Another thing I'd like to show you is that there are some blocks available, like an if block with if then else. If the value after the if returns true, then the then value is returned. Otherwise, the else value is returned. True values are any values that are not empty, like empty strings, and 0 are empty values and they will return false. Anything else will return true. Another block we have is the try except block, similarly as in Delphi. Try, then we enter any kind of expression here that might cause an exception, and an except value that will be returned if an exception is thrown. Like for example, we use an identifier that's not available. It should return 1. Okay, I hope you enjoyed it so far. That's it for now. I don't want to bother you with any more of the details. Thank you for watching.